Hello friends, welcome back to my YouTube channel. So in previous video we have seen the degree of freedom for frames with considering the axial deformation, and we also solved some problems on that. So in today's video we'll go through the degree of freedom for frames by neglecting the axial deformation. So you all know at any joint the possible deformation is 3. So one is vertical deformation, axial deformation, and one moment. The possible deformation is 3. So but in our formula, sometimes in exam they ask to neglect the axial deformation. They ask to neglect this axial deformation. So we'll consider simple frame. We'll know. So this is the frame. So at any joint, usually the deformation will be one is horizontal, vertical, and one moment is there. The degree of freedom is 3 at any joint. So sometimes in questions they ask to neglect the axial deformation, but in frames what happens is whenever it will deform with these two members. The deformation will be like this. I will show. So it will deform like this. So these two members deform simultaneously, so never deform separately. So because of this, the formation of one moment will take place at this joint, and here also formation of one moment and one horizontal will take place. I will explain. So why it's only one moment generate here, I will explain here. Any joint the possible deformation is 3. So here usually at any joint the possible deformation is 3. So this horizontal is axial to this member, this is axial along this member, so it will get cancelled with each other. And this vertical deformation, this is axial along this member, so it will get cancelled with each other. So only one moment is there at this joint. Decay value come out as this joint, the decay value is degree of freedom is only 1. So if you take this joint, again the possible deformation is 3. So this vertical deformation is axial along this member, so it will get cancelled with each other. So the remaining is one rotation and one horizontal. So here one horizontal deformation will come, because we have already considered the member which is axial to this member, we have already cancelled it. So at this joint the possible degree of freedom is 2. One is horizontal, another is rotation. So decay at this joint is 2. So as I already told, degree of freedom at any joint is 3. So at fixed support the reaction is there, and this vertical reaction and the vertical deformation will get cancelled, and horizontal will get cancelled, and rotation will get cancelled. And decay at this fixed support is 0. Same thing here applies here. Decay at this fixed support is 0. So how many numbers? 1 plus 2 is 3. So decay at the structure is 3. So if you calculate by using the for neglecting the axial deformation is 3j minus r plus ec minus m. Here only different thing is we have to subtract the members. So again here we have taken the 3j. Why we have taken 3j instead of taking 2j means, you may ask, here we have to neglect the axial deformation. In previous video we have neglected neglected the axial deformation, we have considered here 2j not 3j, but in case of frames we have to take the 3j not 2j. So why we have to take the 3j means, so we still start with 3j because a joint in a 2D frame has 3 possible deformation. One is axial, vertical and moment. The possible deformation at any joint is 3. So 3j represents the maximum possible freedom, the maximum possible degree of freedom at any joint it represents. So that's why we need to take the 3j here. And you may ask why we subtract m instead of using 2j. If we use 2j, we would be assuming that every joint loses exactly one type of moment, but structure members are connected to two joints. So when we say neglect the axial deformation, we are saying that distance between two joints cannot change. So it doesn't mean the joint can't move. It means the joint's movement is locked to the movement of the joint at the other end of the members. So here each member acts like a rigid link. So one member removes one relative displacement between two joints. Therefore, we subtract the number of members from the total possible deformation, that is 3j. We have to subtract the members in total possible deformation, that is 3j. So that's why we have taken here 3j minus r plus ec minus m, where j is the number of joints, r is the number of reactions, and ec is the number of internal hinge, and where m dash is the number of internal hinge and m is the number of members. Don't get confused here, both are different. So now we will see some problems on it. So we have manually, now we have calculated by using this formula. If we calculate, we will see the answer. How many joints? Number of joints 1 2 3 4 4. How many reactions? 6. Here 3 6. So there is no internal hinge, so EC value is 0. How many members? 1 2 3. So now substitute in our formula. Formula is 3 into J is 4 minus R is 6, EC is 0 and minus M is 3. 3 into 4 12 minus 6 minus 3 9. So 12 minus 9 3. dk will come out as 3 by using with the help of this formula. So when we calculate manually, we got 3. So when we calculate by using this formula, we are getting the value is 3. Both answer will be same. So now we will see some problems on it. So this is a structure. So now we will calculate by using formula. So how many joints? 1 2 3 4 5 6 7 8 9. Number of joints are 9. And how many here? 3. Reaction is 3. Here 3, here 3, here 3. So number of reactions is 3. And how many members? 1 2 3 4 5 6 7 8 9 10. Total members are 10. So there is no internal hinge, so EC value is 0. So now substitute in our formula. dk is equal to 3j minus r plus EC minus m. 3 into j is 9 minus r is 3. R is not 3, r is 9 actually. Make it as 9. So here 3 reactions will take place. Here also 3. Here also 3. So r is 9. 3 into 9. 3 into 9 minus r is 9. EC is 0 minus m is 10. So 3 into 9 27. 27 minus 9 minus 10 19 minus 19. So 27 minus 19 will come out as 8. It will come out as 8. So now if we will see manually. So at this joint, how many possible deformation is only 1, because so this horizontal is, this is axially along this member, so it will, we have to neglect this, and this vertical is, it's axial along this member, so also we have to neglect this also. At this joint only member is one rotation will come. Here also same thing happens, rotation is come here 2. So this vertical is here, this vertical is, this is axial along this member, so it will get cancelled with each other. So only thing we will get is one is horizontal, one is rotation. So why here horizontal comes means there is no any member which is axial to this horizontal deformation, so that at this joint the possible decay is 2. So at this joint again 2, one is horizontal. At fixed support the possible is 0, because here reaction is 3, so deformation is 3, 3 will get cancelled with each other, so decay at this joint is 0. Here also fixed 0, here also fixed 0. So here also again 1, here also 1. So now total add how much it will come. Wait, first I'll write here 1 rotation is there, here 1 is there, here also 1 rotation is there, here also 1 rotation is there, here 2, here 2, here 0 0. So 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 2 6, 6 plus 2 8. So dk will come out as 8 by doing manual. We'll move to next frame. So how many joints are there? 1 2 3 4 5 6 7 8. Number of joints are 8. How many reactions here? 2, here 3. So total number of reactions for how many members? 1 2 3 4 5 6 7 8 9. Members are 9. So now substitute in our formula. dk is equal to 3 into j is 8 minus r is 5. There is no internal limit, EC value is 0 minus 9. 3 into 8 24. 24 minus 5 minus 9 minus 14. So 24 minus 14 10. It will come out as 10. Now we'll see manually. So at this joint the formation of deformation only one rotation will takes place. Here one come, here also one rotation takes place, only one. Here also rotation only one. Here 2, one horizontal, one rotation. Here also 2, horizontal and rotation. Here also the horizontal, one rotation. So at fixed support, as I told, the decay value is 0. So here at inch we'll see the possible deformation is 3 possible deformation. 3, 1 is horizontal, 1 vertical, 1 movement. So vertical gets cancelled, horizontal get cancelled. At in support there is only 1. Decay value is degree of freedom at in support is 1. So now add 1, 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 2 6, 6 plus 2 8, 8 plus 2 10. So decay value at this frame is 10. So now how many joints? 1 2 3 4 5 6 7 8 9 10 11 12. Total numbers of joints are 12. How many reactions? Here 2, here 1, here 3. Total 6. Number of reactions 6. How many members? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So total members 15. So now substitute in our formula. dk is equal to 3 into j is J is 12 minus R is 6. There is no internal range. EC value is 0 minus M is 15. So 3 into 12, 36 minus 6 minus 15, 21. So 36 minus 21 will come out as 15. So now we'll see manually. Here at in support, how many degree of freedom is there? 1. Here 1. Here also 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 1. 1. At roller support, see. So it's vertical will get cancelled. Remaining is 2. At roller support 2. So at fixed, as I told, 0. Here 2. Here 2. Here 2. So now add it. Here 2 plus 2 plus 2, 6. 6 plus 3, 9. 9 plus 3, 9 plus 3, 12. 12 plus 1, 13. 13 plus 2, 13 plus 2, 15. So dk will come out as 15. So this is how we calculate manually. Here vertical and vertical will get cancel. This is horizontal, not this. We'll see. Joints 1, 2, 3, 4, 5, 6, 7, 8. 8 joints. How many reactions? Here 2, here 1, here 2. 5. Total number of reactions are 5. So how many members? 1, 2, 3, 4, 5, 6, 7. 7 members. So now substitute in our formula. dk is equal to 3 into j is 8 minus r is 5. Here internal range is there. We need to calculate the EC1 and EC2. So we will calculate here. So call it as EC1, EC2. So for that we have the formula m dash minus 1. M dash is the how many members connected to this internal hinge. So 2 members connected to this internal hinge. So 2 minus 1 is 1. Here also same thing. 2 minus 1, 1. So now EC is equal to, add EC1 plus EC2. 1 plus 1 is equal to 2. EC value is 2. Substitute here. Minus our M is 7. So 3 into 8. 3 into 2, I will write here. 3 into 8, 24. So minus 5 plus 2, minus 3, minus 7. So 24 minus 3 minus 7, it will come out as 14. It will come out as 14. So 24 minus 3 minus 7, it will become 10. So 24 minus 10 will come out as 14. So now we'll see manually. So at in support, our dk value is 1. So at this support dk value is 1. Here on internal is there. So the possible deformation is 4 because our here the possible deformation 4. One axial will come. This is one horizontal deformation will come. The horizontal deformation is axial with this member, so we have to neglect that. So I am considering only 3 here. 3 dk. Here also same, I am neglecting the axial deformation because it's axial to this member. So here a degree of freedom is 3. Here 3, here 3, here 1, here 2 at this joint. Here also 1 degree of freedom. Here 2 as roller support 2 because vertical get cancelled. Remaining is one moment on horizontal, so 2. Here also one joint is there. Here also 1 comes. 1 deformation will come. Now add it. 3 plus 3, 6. 6 plus 1, 6 plus 1, 7. 7 plus 1, 8. 8 plus 2, 10. 10 plus 1, 11. 11 plus 2, 12. 12. 11 plus 2, 13. 13 plus 1, 14. So dk will come out as 14. So when we calculated manually, we also got the 14. The answer will be same. So this is how we calculate the manually. without using the formula. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.